Good morning. Here we need to show that this given series converges uniformly in this given interval. So here we are going to apply the Dirichlet test, and let's recall that test. The infinite series on the product of unx and vnx is uniformly convergent on E if, first, the sequence vnx is a decreasing sequence of positive terms that converges to 0 uniformly on E. And second, if there exists m positive such that the mod of summation on urx, where r starts from 1 to n, is less than equal to m for all n belonging to the natural numbers and for all x belonging to the set E. Right? Then we say that this given series is converging uniformly. This is the Dirichlet test. So we are going to use this test for the given series. So this is the given series, which can be written as summation n going from 1 to infinity. I can write this as the product of sine of 2n plus 1x into 1 divided by 2n plus 1. So where you can take this as your unx and this to be as vnx. Why I have taken this to be vnx? Because the condition for the test is that the vnx should be the decreasing sequence of positive terms that converges to 0 uniformly. So here 1 divided by 2n plus 1. This is your decreasing sequence, and that converges to 0 as n tends to infinity, right? Isn't it? Okay, let's start with the proof. So the given series can be written as summation n going from 1 to infinity sine of 2n plus 1 x into 1 divided by 2n plus 1. Just take unx to be equal to sine of 2n plus 1x and vnx to be equal to 1 divided by 2n plus 1. The first condition for the Dirichlet test, the sequence vnx, that is equal to 1 divided by 2n plus 1, is a decreasing sequence of positive terms and is converging to 0 as n tends to infinity, right? Since this vnx, that is equal to 1 divided by 2n plus 1, is independent of x, therefore the sequence vnx converges to 0 uniformly on the closed interval AB. Is it okay? Fine? Yes? First condition is done? Alright. Let's move on to the second condition. For the Dirichlet test, we need to take the mod of summation urx, where r starts from 1 to n, and I have to prove that this mod is less than equal to the positive n, right? So this is equal to mod of summation r starting from 1 to n. What is unx? It is sine of 2x plus 1 into x. So urx becomes sine of 2r plus 1 into x. So this further equals to, for r equal to 1, I get sine of 3x, right? So first term is sine of 3x plus, for r equal to 2, I get sine of 5x plus so on, we get sine of 2n plus 1x, right? And the formula for this series is equal to mod of sine of first angle plus last angle divided by 2 sine of nx divided by sine of x mod, as x is strictly greater than 0 and strictly less than pi. This is given to us. And for this interval, we know that the range of sine of x is less than equal to 1. It lies between -1 and 1 for all x belonging to the real numbers. So mod of the numerator becomes less than equal to 1. So this is less than equal to 1 divided by mod of sin x. Right? This is less than equal to 1 divided by mod of sin x for all x belonging to the closed interval ab, as it is given to us that a is strictly greater than 0 and less than equal to x and less than equal to b and strictly less than pi for this interval. So this is equal to mod of cosecant x for all x belonging to the closed interval ab. Let me take m to be equal to the supremum of mod of cosecant x over this closed interval ab. Then mod of summation urx, where r starts from 1 to n, it becomes less than equal to capital M for all x belonging to this closed interval ab and for all n belonging to the natural numbers. Right? So we have proved that mod of this summation is less than equal to positive m. Right? So therefore, by Dirichlet's test, the given series is converging uniformly. So therefore, by Dirichlet's test, the given series is uniformly convergent on the given interval. Alright, thank you. Stay blessed.